Hey, this is John. Welcome to SysEng Quick. Today we're going to be deploying some Talos Linux control plane nodes for Kubernetes. In the next video, we'll add some worker nodes. The cluster is going to span multiple data centers and include physical hosts as well as virtual machines using different virtualization platforms. In my job, we have hosts in different data centers spread across the country. These systems are critical to our operations, and it's a big problem when something goes wrong with one of them. Say we're doing an update and we lose out-of-band access. It could take days or even weeks to get remote hands on site to help. This isn't great from an operational standpoint, so we've been looking for alternatives. Talos Linux is providing us with a new model for our remote systems. If you haven't heard of Talos before, it's a single-purpose Linux distribution focused on running Kubernetes. It isn't based on any existing distribution. In other words, it's not a fork of Ubuntu or Red Hat. It's immutable, so updates are atomic, and you can easily roll back to a previous version if an update were to fail. It's minimalistic, which is a huge plus for security. You won't find any binaries that you might be familiar with from other distributions. There isn't even an SSH server or a shell. You configure everything with a declarative configuration over an API. We'll be placing the control plane nodes in our primary data center because we need low latency for etcd and some control over the firewall. These nodes will be running on OpenStack. We'll be using Kubespan to connect our clusters. Kubespan sets up WireGuard tunnels between the nodes and routes the Kubernetes traffic across those tunnels. Talos discovers the cluster nodes through a public discovery service run by Sidera Labs, the company behind Talos. All we need to do with our firewalls is open a single UDP port on the control plane nodes. The configuration is just that easy. To access our API endpoints, we'll be using Tailscale. This will place all of our nodes into a virtual private network, and we won't have to do anything with the firewalls. It even works if one of our nodes is behind a NAT. I wanted to keep this video short, so we'll just do the control plane nodes for now and do the worker nodes in the next video, and you'll see how easy it is to expand the cluster, no matter where your hosts reside. Okay, let's get started. We're going to need an image for Talos Linux, so I've gone to factory.talos.dev, the Talos Linux image factory. Here, they're going to ask a series of questions about what kind of machine you have, and then they'll provide links to the Talos image. So we're setting up our control plane nodes on OpenStack. So I'm going to select Cloud Server for my hardware type. We can choose a Talos Linux version. It defaults to the latest stable version, and that's the one I'll be using, which as of this recording is 1.10.6. On this page, it's asking what kind of cloud we have. I'm using OpenStack, so I'll select that. We can choose our machine architecture. I have AMD 64 machines, but if you have ARM machines, you would select that instead. This next page is where things get interesting. Talos Linux is immutable, which means we can't add new things to the base operating system after it's installed. So any extensions we want to add need to be included in the Talos Linux image. Now, you can change what image you're using, but you can't change things inside the image. So it's okay if you forget an extension. You can simply replace your image. But I'm going to go ahead and select the extensions I want right away. So there are two extensions that I want. For OpenStack, I'm going to want the QEMU guest agent. And because we're going to be using Tailscale, I'll select the Tailscale extension as well. For customization, this is command line arguments for your kernel. We don't need any, and you most likely won't either. So just go ahead and hit Next. And there we go. We've got our schematic ready. We get a schematic ID, which is the representation of this customization. If you want to use these two extensions, you would get the exact same image ID. So we can go ahead and download the disk image or an ISO. For OpenStack, ISOs aren't really common, so we're going to use the disk image. I could go ahead and download it in Chrome, but I'm going to use the command line with wget instead. Let's go ahead and go to the command line and download our image. Okay, the first thing I'm going to do is set my schematic ID. This is the same ID we got from the Talos Linux image factory. And then I'm going to go ahead and use wget to fetch that image. When we use wget, you can see it took a couple seconds before it started downloading. This can be jarring if you're not used to it. I think the Talos system is queuing up requests to not overwhelm the system. So that's why it may take a few seconds before it starts. However, that's just speculation on my part. I'm not really sure why it happens, but that's my guess. Anyway, I've never seen it take longer than about 10 seconds to start. But if you click on Chrome and it seems to be doing nothing, that's probably why. Just give it a second. It will go. So we now have our OpenStack amd64.raw.xz image. We need to decompress that. So let's use xz-d OpenStack amd64.raw.xz. Now that we have our image file, we need to upload this to OpenStack. So I'm going to use this command right here, OpenStack image create. I'm going to use the public flag. I'm going to use the disk format as raw, and the file is OpenStack amd64.raw. I've already set up some variables, including the image name, so we can hit enter here. I didn't actually run this command because I actually already have this image in my OpenStack, but you would need to run this command if you don't have the image. So I've called it Talos 1.10.6. You may want to set some image properties so that your virtual machines get created correctly. I'm going to go ahead and do that as well. So we're going to do OpenStack image set. I'm going to add these properties: the hardware disk bus, the hardware SCSI model, the QEMU guest agent, the random number generator model, and that OpenStack should require quiescence before doing operations that might be destructive. I can go ahead and enter that. However, all these properties were already set on my image. Let's go ahead and take a look at that image real quick. We can do OpenStack image show Talos 1.10.6, and I will output it as YAML to be a bit easier to read. There we go. I do have that image. We see the image name. We've got the hardware disk bus, the QEMU guest agent, and all the other properties I set. There we go. We're good with the image now. I can go ahead and remove this raw image file. The next step is some more OpenStack preparation. We do need to configure a little bit of the firewall for these nodes. We need to allow the Kubespan WireGuard tunnel port into our control plane nodes. So I'm going to create an OpenStack security group called Talos. OpenStack security groups are basically their implementation of a firewall. Then I'm going to do OpenStack security group. I'm going to give it the name, which is Talos. The protocol is UDP. The destination port range is 51820 to 51820. And I'm going to give it a description. There we go. This is the only thing I have to do on the firewall at all. The next step in our OpenStack preparation is to create our network ports with those security groups for our firewall. Now, in my OpenStack, I have access to multiple projects. Every project has a security group named default, so I can't use the name default because that will confuse OpenStack. I need to get the specific ID of the default security group in my project. So I'm using this command to get that. You won't have that if you have access to only a single OpenStack project, but it's something that I have to do. Now, I actually have two OpenStack instances. I'm going to create two of my nodes in the other OpenStack, but in this OpenStack, we'll create the first node. So I've got a for loop, but we don't actually need the for loop for a lot of it. I'm going to skip showing it on the second OpenStack because the commands are basically identical. So for my host and my one node I'm making here, which I'm calling M1, we're going to use OpenStack port create. I'm going to give it a name. I'm going to supply it the network it's attached to. I'm going to give it the fixed IP from the IP address, and that IPs is an associative array in bash of all the IPs I need. I'm going to give it the security group of the default security group ID that I just found. And finally, I'll add the security group for Talos. Okay, the last preparation step is to generate our volumes. I could create the volume with the server, but I want to name the volume, and as far as I know, there's no way to name a volume while you create a server. So I'm going to go ahead and pre-create the volume. So let's go ahead and do that. I have another for loop, but again, I'm going to delete the M2 and M3 nodes, which you can assume I'm doing on the other server. So we're going to use OpenStack volume create from the image of image name Talos 110.6. I'm going to give it a size of 100 gigabytes. I believe that is the recommendation upstream from Talos. And I'm giving it a type of SSD. That's the name of the SSD type in my OpenStack instance. If you can, you should put your etcd nodes, i.e. your control plane nodes, on SSD, because SSD is good for latency, and etcd is very sensitive to latency. Finally, I'll give the volume a name. Okay, we've taken care of all of the OpenStack prep work, so the next step is to generate the Talos configuration. To generate the Talos configuration, we're going to need the Talos control binary. So if you don't have that installed, you'll need to install it. Or you can run it from Docker. I won't be doing that in this video, but I'll show you an example of that in the next video. So I do have Talos control installed here, so we'll go ahead and use that. I'm going to create a directory for my Talos configuration. I will need to save all the files that it generates because they are the keys to my cluster. If I lose access to these keys, I will no longer be able to manage my cluster. So make sure you preserve these files in a password vault. So the first step I'm going to do is Talos control generate secrets -o secrets.yaml. So I'm making secrets and putting them in a secrets file. This is basically my private keys and information to connect to the cluster with those authentication mechanisms. Then we are going to generate the configuration. I'm going to use Talos control generate config with my secrets file. I'm going to use with Kubespan to enable Kubespan. I'm going to set a specific Kubernetes version. Now, you don't have to do this, and by default, it will pick the current stable version that Talos control knows about, which I think is 133.3 in the 110.6 version. Then we need to give it the cluster name. You have to name your cluster. I'm calling mine light. I've got a variable for that. And finally, it has this kind of confusing endpoint string. So the endpoint is simply however you connect to the Kubernetes API. So there are a lot of ways to do that. The easiest way is just to say that your endpoint is the first control plane node. So if I had the IP address of that, it'd be https:// IP address :6443. I am actually using DNS round robin because I don't have a load balancer set up for this right now. So my endpoint is actually just DNS round robin. So if I dig for that endpoint, you'll see they are the public IPs of those control plane nodes. Now, this isn't actually what I want. I want to use the Tailscale IPs, but I don't know what those are yet. I'm not sure if you can pre-configure those before you join a node to the cluster. So we'll change that later, but it'll work fine for now, and it won't get any DNS NX records from them not existing. So that's what I wanted currently. But most of the time, you will use a load balancer, and then your endpoint is going to be the load balancer name or IP. And that's what we'll probably do later on, but it's not what I'm doing right now. Okay, that is the basic generic configuration. You can see we've got a control plane file, a worker file, and a Talos config. The Talos config is the most important one because that is the way you connect your config to your cluster and do authentication. So if we cat that file, you can see it's got certificate authority, certificates, and keys. It looks very much like a kubeconfig file. That's not by accident. The authentication mechanisms for Talos are very similar to Kubernetes because they are trying to be the Kubernetes-focused distribution. It makes sense they'd want to emulate that. Okay, the other files are going to be the control plane file and the worker file. These are the generic files that it's going to use to configure your control plane or worker nodes. And they are heavily commented so you can generally understand what these values are doing. But you can also get more documentation from their website. Their docs are very good. So these generic files will get us pretty far. It's got the certificates and the joining key and all kinds of useful stuff in here, but we may want to configure a few options in this file. Now I've got 3 control plane nodes. I don't want to edit this file 3 different times. So instead, we're going to patch this file and make a specific file for my control plane nodes. So for instance, we do have the network Kubespan feature enabled. However, we are not setting a host name. And by default, OpenStack picks what are, in my opinion, terrible host names that look awful. I want to set the actual host name for each of my hosts. So let's go ahead and patch my configurations and see how that works. So I'm going to run another bash for loop. So for host in M1, M2, and M3, that's what I'm calling my control plane nodes, I am setting up a patch file with maketemp, and then I'm using cat to output to that patch file. And the patch file is just another YAML file, whatever we want to override. So in machine network hostname, I have my host name. In the name servers, I am adding the Tailscale name server first. Now, this is specifically for Tailscale and the control plane nodes, and I'll explain the purpose of it a little bit later. But it is important I have this in here if I want to use short names, which I do. We also give it the IPs of my other DNS servers. You want to make sure you don't have only the Tailscale DNS server, because it will take Tailscale some time to come up, and if it isn't up, you won't be able to reach that name server, and Talos kind of freaks out when it has no DNS and does very weird things. So make sure you have working DNS servers. If you don't want to use your DNS servers or don't have them, just use Google's or Cloudflare's or whatever. I'm adding the search domain for the Tailscale domain. We'll see why later. And then finally, I am adding another document, and we are adding this extension service config. This is how I configure Tailscale. All I have to do is set this environment key, which is my Tailscale joining key. I got that from the Tailscale admin panel. So you'll need to make a key for that as well. Finally, we'll run the command talos control machine config patch. I'm patching the control plane file with my patch file, and you need to use the @ symbol because it's a file, not an inline patch. And then we're going to output that to either M1, M2, or M3.yaml. And then I'll remove my patch file because it's a temp file. There we go. We've got all of those files. Let's take a look at, say, M1.yaml. You can see all of the comments have been removed. We don't need them anymore. I do have my host name set in here. I've got my DNS name servers and my search domain. So yeah, the patch went pretty well. You can see we do have our specific Kubernetes version. This was already in controlplane.yaml because I specified that when I did talos control generate config. So everything here looks pretty good. I think we're ready to actually create our control plane nodes with these files. To do that, I will use another for loop, although for this OpenStack, I don't need that for loop, so let's just do M1 node. We're going to do OpenStack server create. I'm going to give it the name. I'm going to give it a flavor, which in my case is M1.large. That has 4 CPUs and 8 gigs of RAM in my OpenStack instance. I believe that is the Talos upstream recommendation for control plane nodes, although you may need different requirements for your servers. The NIC is one of those network cards I created earlier, and then the user data is that config file we had earlier. It's going to be the m1.yaml file for this M1 node. And finally, I'll tell it to boot from the volume we created earlier. There we go. And I will go ahead and, oh, I'm in the wrong place. Hang on. Let's go back to the correct OpenStack one. And then over here on the second OpenStack, we will do M2 and M3. Okay, it's built the M1 node, or it is building that. Okay, now that all of the servers are up, let's go check in the OpenStack console and see what they look like. So here is our M1 node. It's in the stage booting. It says the cluster is light. It's got 3 machines in there. The Kubernetes version is 132.7. We've got several IP addresses. The 100 IP is the Tailscale IP. The IP ending in 207 is my public IP. And then we've got the other FD7A and FDAA, which I think is something to do with Kubespan. I'm not quite sure about those. But you can see it is kind of stuck. It's not ready. It's in stage booting. So what is going on here? This one is in stage booting, and the ready part has been cut off on this one. That's one of the downsides of the OpenStack console. It's very tiny, and I'm not sure why, because the iDRAC consoles aren't so small, but the OpenStack and proxmox consoles are very small. We'll see another way to get this information later on that's not quite so limited. But the M2 node and the M3 node are all in the same place. We just can't see the ready false on the other 2 nodes. So, we should be seeing an error message. There we go. Talos etcd is waiting to start. Harry kind of passed it by, but yeah. Well, it'll spam that message on the console every once in a while, telling you if this is the first node in your cluster, you need to run, there it is, etcd is waiting to join the cluster. If this is the first node in the cluster, please run Talos control bootstrap against one of the following IPs. So that's what we need to do next. We need to bootstrap our etcd. So let's go back to the terminal and do that. Okay, the first thing I'm going to do is do Talos control config merge with my existing Talos config. So I have now copied this Talos config into the Talos config main file. So just like with Kubernetes, you can manage multiple Talos Linux clusters in the same file. Now, I'm not doing that right now, but it does at least place this in the correct location, so I don't have to reference my Talos config in this directory every time I run a command now. I'm going to go ahead and add some endpoints. So I'm going to do Talos control config endpoint M1, M2, and M3. The endpoints are the APIs I want to connect to. So we connect to an endpoint, talk to the API, and then we specify the node we want to actually run the command against. So there's a difference between endpoints and node. It's a little bit subtle. So now I can do Talos control bootstrap. So, and I can use it against the M1 node because I do have this in my tailnet. This host is in there. So M1 is my M1 node, and M2 and M3. And they are using the tailnet IPs. So let's go see what's changed on the console. We can see it's gone from stage booting to stage running. It's not quite ready yet. It will take 30 seconds or so before it's going to be up, maybe a minute. But it will get everything running shortly, and everything should be good. So this one is still in stage booting. It hasn't joined the etcd cluster yet. Same thing for the third node, but there you go. This one is now running. This one is still booting, but it will get there shortly. So let's go back to the console, and I'll show you the other way we can look at this dashboard information. So on my command line, we can do Talos control dashboard, and we can give it the nodes M1, M2, and M3. There we go. Here's our M1 node, and you can see there's a lot more information the console is kind of cutting off. So we can see the stage is running. It's still not ready. Secure boot is false. Well, we're not using UEFI, so that makes no sense here, but that's fine. Kubelet is healthy, but the API server, controller, manager, and schedule are not ready yet. But they should go ready pretty soon. You can see on M2, API server, controller, manager, and scheduler are all healthy, but it still isn't quite ready yet. And then same thing on node M3. So yeah, everything is now healthy on all the nodes, but we're still not quite ready. It has to do a little bit more configuration before we'll be ready. But I'm going to say 30 seconds and we'll all be ready. There we go. M2 node is ready. And I can use the arrow keys to go back and forth between my 3 nodes. There we go. Everything looks good now. Everything is healthy. All 3 nodes are ready. So everything should be good with our cluster now. So let's see if we can get the kube config and see what that looks like. I'll go ahead and quit that. And I'm going to run talos control kubeconfig-n on M1. We can get it from any of the nodes, and that puts things into my kube config file. So that's how it accesses my cluster. So let's do kube control get nodes. And it's just hanging there. So remember when I told you I set this up with this DNS round robin entry, but they have the public IPs, which are firewalled off from this particular device right now. So that's not going to work. So I can either update this DNS record with the tailnet IPs, which that's what I'll do later, but just temporarily to get this working and show you that it is actually working, we're just going to go ahead and modify this, and I'll pick the IP address of my first server on the tailnet, or rather I'll use a short name, which is M1. So now I should be able to do kube control get nodes, and I can. And you can see all of the control plane nodes are ready and they're up. Okay, there we go. That's it. We have successfully set up Talos Linux control plane nodes. In the next video, we will add our worker nodes. Hope you enjoyed today's video. Hope you learned something. If you did, go ahead and hit those like and subscribe buttons. Come back next time when we'll do the worker nodes. Thanks for watching. See you then.